Hello, screen is visible. No, am I audible?
Sir,
Okay.
somewhat glitch is there, sir.
Now it is not visible. Should I stop it?
Visible, sir. Your voice, sir.
Not clear.
Now it is okay, sir. Now
Okay.
it's clear, sir.
Okay. Okay. So this PPT already I have shared previously. So sinusoidal PWM, how it will work. This is half bridge inverter. Already we have discussed earlier. For normal like PWM kind of a square wave of there. So here what we are doing, we are comparing a sine wave with a triangular wave. So sine wave will called as modulating signal and carrier wave will be the triangular signal. Okay, so this will be high frequency signal and this will be a 50 hertz sine wave. So this is the logic for sine PWM. If S1, if reference is greater than carrier, okay, reference means modulating signal. This one, this is VR and this is VC. Okay, if VR is greater than VC, then S1 will be on and S2 will be off. And if VR will be less than VC, then S2 will be on and S1 will be off. Okay. So in this case, we'll get this kind of PWM signal for S1 and S2, and corresponding we'll get the high frequency oscillating output voltage. Okay. So if we'll do the Fourier analysis of this one, okay, if we'll do the Fourier analysis of this kind of waveform, only fundamental will get this one. So only we have to like no need to think about other harmonics because I've seen many books like no correct derivation is given for this kind of waveform in terms of nth harmonic. Okay, that is not possible to derive. So some approximate formula they are using, and with using that approximate formula, they are deriving this fundamental value. So fundamental output voltage across the load will be MA into VDC by 2 sin omega t. So here this maximum is VDC by 2, minimum is minus VDC by 2. So this formula we have to remember, and these are some terms like modulation index. So modulation index means peak value of the reference signal, means modulating signal, divided by peak value of the carrier signal. So carrier signal, it will be minus 1 to 1. Okay. So this peak will be 1. Let's say if the sine peak is 0.8. Okay. If peak of the sine wave will be 0.8. So the modulation index will be 0.8 divided by 1. That will be 0.8. Okay. And one other term is there, frequency modulation ratio, MF. So MF will be carrier frequency divided by reference frequency. So is it clear up to now? Right.
It is reverse for modulation index to frequency modulation index, sir.
Which one? This.
Here, carrier by reference here,
Yes,
reference
yes,
by
yes.
carrier. Now.
Yes. So frequency modulation ratio is the carrier by reference, FC by FR. So let's say this carrier frequency is 500 hertz, like 5 kilohertz. Okay. And this reference frequency is 50 hertz. So what will be the MF value? MF will be 500 by 50. That will be 100. Is it clear? This is frequency modulation ratio. This is different thing. One term is there, and this is modulation index. Okay. So modulation index means reference peak divided by carrier peak. Is it clear up to now? So see, this formula only we have to focus. Mostly question will be based on this formula. So we have to memorize this MA into VDC by 2. So in half bridge, the voltage will be VDC by 2. Okay. That's why how we can remember MA into VDC by 2 into sin omega t. So this is the peak value, MA into VDC by 2. What will be the RMS value? So RMS will be MA into VDC by 2 root 2. This will be the RMS value. Is it clear? Okay. So see here, same one circuit I have simulated in MATLAB. So what data I have taken, DC voltage I have taken 100 volt. Okay. and reference frequency, sine frequency 50 hertz, and carrier frequency of 1050 hertz, and modulation index 0.6. Okay. So what will be the value of MF? MF will be 1050 divided by 50. How much? 21. So this is frequency modulation ratio. Already this term I have defined here. Okay. So if you will see the RMS value, this one I have calculated from MATLAB. So if you will plot in MATLAB, there one FFT window is there. We can apply the fast Fourier transform. We can draw this kind of a spectrum, harmonic spectrum. Okay. So x-axis here is harmonic order, means 0th harmonic, 5th harmonic, 10th harmonic. Okay. So if these are some notes like harmonic, where it will go, it will distribute across MF, 2MF, 3MF, 4MF. So if you'll see here, this is fundamental. Okay, but our harmonic is getting across this point and this point, and if you see the THD is 200, 213.99%. Is it clear? See
Here
here.
fundamental is 30 hertz now, sir. Here 50 hertz equal to 29.92 watts, so that value.
See, this is peak value it is giving. If in MATLAB, if you do the Fourier analysis, fast Fourier transform, so how we can do? We can simulate this circuit. Okay, then we'll get this kind of waveform. For this waveform, if I apply the FFT, then I will get this kind of Fourier window, like Fourier series. So these are the amplitude of the harmonics. Like this is fundamental 100%. So fundamental peak value it is giving. Peak value of the fundamental. Okay.
Okay,
Okay,
sir.
so if we'll apply this formula, this is RMS value, but what will be the peak value? Can you calculate the peak value of this one? That will be 60 by root 2, M into VDC by 2. This will be the peak value. So 0.6 into 100 by 2, how much? 30 we are getting.
Yes, sir, 30.
So here also see almost same we are getting. Since this formula is not 100% accurate, it is some, this fundamental formula is not 100% accurate. Little bit approximation we are using here. That's why, but MATLAB, what it will give? It will give 100% accurate result based on this waveform. Okay, so that's why we are getting here 29.92. But whatever numerical we will solve, we will use this formula. Is it okay up to now?
Okay,
So
sir.
just we have to memorize this one. So numerical question can be framed like this one also, like based on MF also. Till now no question came in gate. So frequency, like they can ask harmonics will be like get distributed across, like which. So here we'll see MF means 21. If you see here, this is 21. Across 21 only harmonics are getting. Here also if you see 2MF, 42. So harmonics are getting distributed across the MF and 2MF. This thing we should remember. Okay. And the fundamental equation. And see here, one thing is also, the harmonic can be characterized as follows. HF is equal to J into MF plus minus K. If K is odd, okay. And if J is even, K is odd, and if J is odd, K is even. What it means? Is it visible from, something is visible from this waveform? See, HF can be characterized as follows: MF plus minus K, J into MF plus minus. J is odd, K is even. What we are getting from here? Think, see, let's say what is MF 21. Okay. So see here.
Alternate, sir.
Yes. Am I audible? So MF is 20.
Alternate, sir, that one.
No, no. J and K two value we are taking. MF we are taking. So See, somewhere here nearby it is 0. Nearby it is almost less, but here it is higher. Okay. So 21 J into MF plus minus K. Okay. So let's say this is what 21 less than 1, how much? 20. And 22, there it is not there, but 23 it is there. And 1 second here. See, this only it is shown here. If we'll see the harmonic pattern here, so nearby it is less only here, here and here, just side by side. But after one it is higher. If we'll see here also, you have to zoom it. 1 second. Exact data is not shown. 1 second. So if you see here, I think this is 21st. Okay. And 40. Actually, if you'll see the actual MATLAB plot, then it will be more clear. Okay. Here it is not visible. So this only it is shown here. Like this is, I think 21 or 20, 21, 22. 1 second. Okay, we'll discuss it later. I think it is not clear. If I will share the actual MATLAB plot, then this is not much more important. Okay. Main thing is it is getting spread across MF, 2MF, 3MF, and 4MF. Okay. Is it clear up to now? Hello?
Yes, sir. Clear, sir.
Okay. So main our interest will be this formula. This will be the most important. Okay. And this one also. So moving to the next part. So this is same thing for full bridge. Okay. For full bridge, what will be the logic? This is the sine wave. If VR will be greater than carrier, then S1, S2 will be on and S3, S4 will be off. And if it will be less than carrier, then S3, S4 will be on and S1, S2 will be off. Okay. Where VR and VC are the magnitude of the modulating and carrier signals. Already same thing, but here we are getting VDC and minus VDC. So formula will be, previously we are seeing M into VDC by 2. But here, since voltage is VDC, VDC and minus VDC, if you see here, this is VDC by 2 minus VDC by 2. So formula will be same here. 1 second. Where it was? So formula will be same here, but MA into VDC. Is it clear? It will be same. Every other thing will be same. So this we have to memorize here. Is it clear? So for
Yes,
harm,
sir.
so coming to the next, same thing I have done here also. Like simulated the same thing for 100 volt, 50 hertz, and 1050 hertz. MA is equal to 0.6. So we got something 59.88 up almost 60. It should come 60 volt peak value. So 0.6 into VDC 100. How much? 60 volt peak value. And RMS will be 60 by root 2. That will be 42.42 volt. Okay. See why THD is higher here. Like in last session, someone has asked like THD can be greater than 100% or what. So if you see the RMS value, actual RMS value, what will be the actual RMS value of this signal? Hello, that will be 100 volt. Can you reply? Am I audible?
More than 100, sir.
See, the actual will be 100 volt, but fundamental will be how much? 42.42 volt. What will be the THD? What will be the distortion factor for this one? What will be the distortion factor? Fundamental by this one, VS1 by Vs. So that will be 42.42 divided by 100. So can you calculate the THD value for this one? THD, how much we are getting by calculation? So DF will be 0.04242. Is it correct? And THD will be 1 divided by 0.04242 whole square minus 1. Oh, hello. Am I audible?
Yes, sir, audible, sir.
We are getting the same thing or different? One second. I'm getting 23.55. Anyone got this value? I think I have done some mistake here. 0.4242 it will be. We are getting this value 214.8 almost. Hello. 1 divided by 0.4242 whole square minus 1. I'm getting 213.76%.
Sir, 2.134 into 100, 216.4, sir.
Okay, so see, THD is greater than 100%. Here also we are getting the same with. So this can be possible if our fundamental value will be less than the actual voltage. Is it clear?
Sir, once again, sir, that one, 100,
See, 100 is the actual RMS of this output value. Output voltage is this one. It will oscillate between plus 100 and minus 100. So actual RMS value will be constant 100 volt. But the
hmm,
fundamental value will be, RMS value will be 42.42 volt. Okay. So based on this,
okay.
we are calculating THD value and we are getting this much percent. So see, this kind of question also they have not asked till now. Maybe they can ask what will be the THD of the output voltage. Okay, this type of question can be framed. So coming to other thing. So one other technique is there that was previous was bipolar. So see, this technique was bipolar PWM. This technique is called as bipolar PWM for full bridge inverter. And here this technique is called as unipolar PWM. Okay, unipolar sinusoidal PWM, but the actual formula will be same here also. Either it will be bipolar or unipolar. Here this is the output voltage. Okay, but what will be the formula of the RMS value? MVDC sin omega t. Here also it will be same. Okay, but the logic is when two reference signal we are using, one is sine and another is reverse of the sign, and triangle will be same only. So when VR will be greater than VC S1 on, and VR will be R1. R1 means modulating signal 1. VR1, this is VR2. And when VR1 will less than VC S41. Okay. Similarly, this logic is there. If we'll apply this logic, we'll get this kind of PWM signals, and output voltage will be like this. Okay. If we'll do the Fourier analysis of this one, this will be the fundamental voltage. So we should remember this one. Is it clear up to now? Hello.
Clear, sir.
Okay. So same thing I have done here also. This one part also I have simulated. So here one thing is like our harmonic will previously it was getting concentrated across MF to MF. Okay, but what is happening here, because of this some subtraction is happening across the pole voltage. Okay, that's why if you see the signal frequency like this is the twice of the frequency of the output voltage will be twice of the carrier frequency. See here, if you'll see, very big signals are there, but if you'll see here, very small pulses we are getting. Okay, that's why here our waves, see here also, if you see the frequency of this one, this triangular wave, that is, one second. frequency of triangular wave is 1050 hertz. But if you will see the output voltage, that is very small are there. It means it is getting double the frequency because pole voltage we are subtracting, this pole voltage minus this pole. After subtraction, we are getting this kind of voltage. Okay. That's why what is happening, it is getting concentrated across 2 mF, 4 mF, 6 mF. Okay. So what is the mF here? mF is 21. So if you see here, this is 42. It is across 2 mF, it is not, harmonic is not there. Okay. And the RMS value here also we are getting same, almost 60. 1 or 2 volt less, 60 volt peak value. Is it clear? Hello.
Clear, sir.
Okay. So based on this only, I have taken 1 or 2 questions. Go quickly. So this is asking GATE 2016. Okay. And the question is, this is a half bridge inverter. Okay. VDC by V2, VDC by 2 is already given. And this is the modulating signal 0.8 sin 200t, and the triangular carrier signal is of frequency 5 kilohertz. The peak value of 100 hertz component in the IL. Okay, so 100 hertz component means what? Fundamental, because if you see the modulating signal, what is the frequency? 2 pi into 100. So frequency of the modulating signal is 100 hertz. Okay, so we have to indirectly we have to calculate the fundamental value. What will be the RMS value of the fundamental value? That will be MA into VDC by 2 root 2. This only will be the value. Is it correct? So what will be this value? 0.6. Okay. VDC by 2 already it is given here. So VDC by 2 will take here. Okay.
Sorry, MA 0.8 now, sir.
Okay, 0.8, correct. So 0.8 into VDC by 2, how much? 250. See, if here we have to be careful. See, if this kind of VDC will be given, here only will do the mistake. See, if this is VDC and capacitor will be given, okay, then it will be VDC by 2, VDC by 2. But here only if some voltage will be there, then that only will be the VDC by 2. Okay. So MA into VDC by 2 already it is there, divided by root 2. So how much this value will be? And impedance also we have to calculate. So 16s Z will be under root 16s square plus 12.
Sir, VDC by 2 equal to 250, sir.
Uh,
You written 230.
250.
Okay,
Okay.
sir. Okay.
0.8 into 250 by root 2. 0.
Sir, 141.42, sir. That one.
How much? 130?
141.42 volts.
141.42. What will be this Z value? 16 square plus 12 square plus 12 square. 20 we are getting this one. 1 second. The peak value, see here one thing we are doing mistake. What they are asking? They are asking the peak value, not the RMS value. 100 hertz
So root
component.
is not there, sir.
So root 2 is not required here. This thing we should be careful. If they will ask RMS value or peak value. So how much will be this value? 0.8 into 250. So our current will be 0.8 into 250 divided by 20. Since Z is 20. Okay.
So V01 is 200 volts, sir. 200 volts.
This one we are getting 200.
Hmm.
Okay. So 200 divided by 20, that will be 10. So the peak value of this current will be 10 ampere. Is it clear? So here this thing we should be careful what they are asking, the peak value of the current. So the peak value of the voltage will be M into this root 2. I am going to V01 peak will be MA into VDC by 2, MA into 250. Okay. Is it clear to all?
Yes,
See,
sir.
okay. So this next question they have asked in GATE 2017. Okay, but this is also same. But see here, this VD here also VDC is there. VDC by 2 is not there. Okay, so what is VDC value given? Where it is? VDC we have to calculate. The value of the DC voltage we have to calculate. RL load is there, drawing a power of 1.44 kilowatt. This load is drawing a power of 1.44 kilowatt. R is equal to 40 ohm. L is equal to 0.3 by 5 Henry. Okay. And the fundamental frequency is 50 Hz. The switch of the signal converter using SPWM with modulation MA is equal to 0.6. So with this current power value, can we calculate the current flowing through this one? Because only resistive part will consume the real power. So I square into R, that will be 1.44 kilowatt. How much will be the I value? I will be 1440 divided by 40 under root. How much will be this value? 1440 by 40. 1440 by 40. This we are getting a 6 ampere. This is amplitude of the current. Okay. So what will be this is RMS value. Is it clear? This is RMS value of the current. Clear to all?
Yes, sir. Clear, sir. That one.
So
Clear, sir.
same current we can calculate at V01 RMS divided by mod Z. So that will be this current. Okay. And what will be the X value here? Since this frequency is 50, so 2 into pi into 50 into L, 0.3 by pi. Pi will cancel. How much it will be? It will be 30.
30 ohm, sir.
30 ohm. Okay. So what will the Z value? Z will be 30 square plus 40 square.
50, sir. That one.
50 we are getting. Okay.
Mm.
So Z we got. What is V01 RMS? So we can calculate from here. V01 RMS will be Z into I. Okay. So V01 RMS. V01 RMS will be Z into I. I we already got. So how much? 6 into 5. That only?
6 into 50, sir.
6 into 50. Okay. But what is the V01 RMS formula? That is M into VDC. VDC?
By 2.
No, not by 2. That divided by root 2.
Root 2.
Because here this VDC itself is given. This is not VDC by 2.
Okay. Okay, sir.
So here we have to consider VDC only. Here we have to be careful. Okay. So 0.6 into
Sir,
VDC.
here VDC we can take as a capacitor value. Suppose.
See, if this capacitor will be there, two capacitor will be there, and here one VDC will be there. Okay.
Yes, sir.
So
Here
here it
two
will come as
VDC there,
VDC by 2. So
and source is two
so
VDC.
so if here it is VDC, then source will be 2 VDC. Okay. So if we will take 2
Okay,
VDC, so 2 VDC by 2 will be VDC only. I think it will be clear. So see, 0.6
Yes, sir. Clear.
VDC by 2, this should be equal to how much? 6 into 50. So what will be the answer? This 6 will be 10 times, so 500 root 2. VDC will be 500 root 2 from this equation. So C is the correct option. Is it clear to all?
Sir, but we have to find that source voltage, no, sir.
Source only. That VDC is the source voltage only, na?
But this in this VDC it is across capacitor, no, sir.
See, this value only we have found, na? VDC. See, if you go to that circuit, what I explained, bridge. So here, VDC was here. and then VDC by 2 was coming here. So whatever voltage will be here, that voltage into MA, that will be the peak value. Okay. For,
Okay, okay, sir.
so here, 1 second. So here this voltage VDC into MA only will come. That peak value. RMS will be VDC into the 0.6 by root 2. Is it clear?
Sir, clear, sir.
Okay, okay. So now I'm moving to the three phase. One by one I will go quickly. So three phase, two modes are there. Two modes of operations are there. So first step is we should remember the circuit diagram. Okay. Same as rectifier. This is 1, 2, 3, 4 and 5 and 6. Okay. And this is a star connected load. This is a neutral and this is DC source voltage. So how we can remember in that 180-degree mode, every switch will conduct continuously for 180-degree. Okay. And after each 60-degree, another switch will conduct. So how we can remember the switching logic, I will explain. See, first what I will do, step 1, we'll draw 3 straight lines. After that, 60-degree, I will make 6 sections, 1, 2, 3, 4, 5 and 6. Okay. So I am starting the one switch here. So one will conduct from here to here, 60, and after 60-degree here, 2 is starting. Okay. Again, after 60-degree here, 3 is starting. So one is conducting from here to here. So 1 and 4. See, 1 I have started here. So in one line, this opposite line will come after 180-degree. Similarly, 6, 3. So 3 I have started here. 60. After 180-degree, 6 will come because 3 and 6 are in same leg. 1 and 4 are in same leg and 2 and 5 are in same leg. Okay. So here I have started at 1 I have started here. So after 60-degree, 2 I have started here. Okay. So 2 will conduct for 60, then 5 will start here. Okay. Similarly, after 2, this is 60-degree. So 1, 2 and 3. After 60-degree, 4. After 60-degree, 5. After 60-degree, 6. Is it clear? This timing diagram? Like this way we can remember. This is the switching sequence for 180-degree conduction mode. Is it clear?
Yes, sir.
How to remember? Okay. So this way we can remember it. Of see, if 1, 6 and 5, so in this 3 switch will conduct at a time. At a time in this mode, 3 switch will conduct. So if 1 and 6 and 5 will conduct, what will be the VAN voltage? Okay. So 1 will conduct, 6 will conduct and 5 will conduct. So see, 6 and 5. So what will be the, so see, 1 is here, 5 is here and 6 is below. So can we apply voltage division rule here to get the voltage across VAN? So circuit will be like this. Let's say 1 is conducting. So 1 will be at top. Okay. And then our this 5 is conducting. So 5 is also connected at top. From top plus it will connect. Okay. So it is connected to plus VDC. And another 6 is below. So 6 will conduct means this will connect it to minus VDC. So this will connect to minus VDC. This is plus, this is minus. So this is N point and this is A point. What is AN value? This ZZ, it will be Z by 2. Okay. So Z by 2 divided by Z by 2 plus Z. How much this factor will be? 1 by 2 divided by 3 by 2. That will be, yes, Rajnish, you can ask. Hello.
Yes, sir.
So this will be 1 by 3. See, any doubt is there, you can just unmute yourself and ask.
Okay, sir.
Is it clear how? So this, that's why here Vs by 3 is there starting. First 60-degree, just voltage division rule I am applying. If 1 is conducting and 5 is conducting, it means A and C point will be connected to plus VDC. Okay. And this is neutral point. And B point will be connected to minus VDC. This is plus minus Vs. Okay. And this 2 equivalent will be Z by 2. So VAN will be Z by 2 divided by Z by 2 plus Z into Vs. So that will be Vs by 3. Is it clear?
Yes, sir.
Similarly, if 1, 6 and 2 will conduct. So 1, 6 and 2 will conduct. In that case, two impedance will be connected to bottom point and one will be connected to top point. Okay. So in that case, the case will be one will be Z will be like this and this two will be like this below. Okay. So here N is there and VA. So VAN here will be 2 Vs by 3. How? Because Z by 2 Z, this is Z. So Z divided by Z by 2 plus Z. Okay, this will be 2 by 3. Is it clear? So similarly, for all cases, we can just apply voltage division rule and we'll get this kind of waveform, phase voltage, VAN. Is it clear to all? Otherwise, I explain all the sections I will explain. Hello? If it is not clear, you can ask. Am I audible?
Sir, can you explain once again, sir?
See, first case, which switches are conducting, switch 1 is on. See here, first 60,
1,
6 and 5. Okay.
165.
So, okay, 1 and 5 will conduct means this A point and C point will be connected to plus VDC. 1
Yes,
means
sir.
A point is connected to, and 5 means C point is connected to VDC. But 6 is means B point will be connected to which? Minus VDC.
Negative.
So this is minus, this is plus. Okay. Where is our A point? A point is here, C point is here, and N point is here. But I want to calculate this VAN. Okay. So VAN, but here plus and here minus, this voltage is Vs. Okay. So across this plus and minus, what will be the voltage? That only will be the VAN. But these two impedance are connected in parallel. So parallel impedance means Z by 2. Okay. And this impedance
Yes, sir.
is Z. So we can apply voltage division rule. So the voltage will be Vs into this top impedance across which we want to voltage. So Z by 2 divided by Z by 2 plus Z. Bottom is the Z.
Divided by total. Yes, sir.
So
Total
that we are
resistance.
getting as 1 by 3 Vs. So here
Okay,
0
sir.
to this first 60 degree Vs by 3. Similarly for second case. So second case
Sir,
1, 6 and 2.
2, yes, sir.
2,
2,
6 and
6, and 1 conducting.
see. So 1 is conducting means what will happen? This top A will be connected to N point. Okay. And 2 and 6 means conducting means this is B and this is C. This is connected to minus point.
Yes, sir.
So if here we'll
Minus
apply
point.
the voltage division rule, what will be this voltage? VAN. So VAN will be Z divided by Z by 2 plus Z, because we have to calculate voltage here, phase A voltage. Here also we have calculated phase A voltage. Here also phase A voltage. So what will be this factor? This factor will be 1 divided by 3 by 2. So that will be
3 by 2.
2 by 3.
Yes, sir. Yes, sir.
So see, like this you can analyze for all the sections. Okay. So here for first it is Vs by 3. Next we are getting 2 Vs by 3. Again we'll get Vs by 3. Similarly here it will come minus Vs by 3, minus 2 Vs by 3, and here it will be. So this is our phase voltage for A phase. Similarly for B phase, this will be the value. Okay. And what will be the line voltage? So line voltage means phase A minus phase B. Okay. So here I have plotted the line voltage. See, if we'll subtract this one minus this one, so here Vs by 3 or here minus 2 Vs by 3. So Vs by 3 minus 2 Vs by 3, how much? That will be Vs. Is it clear? This is line voltage. Is it clear to all? Hello. See this voltage I am subtracting from this. So VA minus VAN minus VBN. So here it is Vs by 3. Here it is minus 2 Vs by 3. So it will be 3 Vs by 3, that will be Vs. If you'll see here 2 Vs by 3 and 2 Vs by 3 plus Vs by 3, here also it will be Vs. But here to here, this is 2 Vs by 3 and this is also 2 Vs by 3. That will be cancelled and it will make to 0. So this is our line voltage. Okay. Now coming to the formula,
Okay, sir.
how we can derive the formula? This line voltage formula we can derive from this waveform. So it is conducting for 120 and 120, 240. Okay. So line voltage will be Vs into 240 divided by 360. So our line voltage will be Vs into root 2 under root 2 by 3. This is the RMS value. Okay. RMS value of the for one line voltage for 180 degree conduction. So that is Vs into root 2 by 3. What will be the phase value? Phase value we can derive from this voltage, okay, which we that we will get as root 2 Vs by 3. But directly what we can do, we will remember this formula. And what is the phase value? Phase is line divided by root 3. Okay.
Divide by
So
root
so if you
3.
divide this by root 3, that will be root 2 Vs by 3. Okay. So now I'm moving to the 120 degree mode of operation. 120 degree, what will happen? See here, it is conducting for this. So if two switches will conduct simultaneously, what will happen? Let's say 1 and 4 will conduct at same instant. What will happen? That will create a dead short circuit across the source, and a very high current will flow and switches will get burned. Okay. So that's why what we are doing, we are creating a gap of this 60 degree between two switches, okay, such that in same leg two switches will not conduct simultaneously. Because if we are not creating a gap and by mistake if two switches will be turned on, it means like before turning of the one, if 4 will be turned on, what will happen? Both switches will turn on at same instant and it will create a dead short circuit across the source. Okay. So to avoid this issue, the 120 degree conduction mode is a solution. So here, this is the timing diagram for this one. So switch 1 will conduct for only 120 degree. Again, this gap will be there. Then 4 will conduct for 120 degree. Okay. And same way we can derive the, 1 second. Okay. See, so same way voltage division rule we can apply and we can derive the phase voltage. So if 1 and 6 will conduct, what will happen? One is conducting means A is connected to plus VDC, okay, and 6 is conducting means B is connected to minus VDC. This is N value, plus minus. What will be the voltage? VAN. Is it clear? That will be Vs by 2. Vs into Z by Z plus Z. Vs into Z by Z plus Z. That will be Vs by 2. So here it will be Vs by 2. If 1 and 2 will conduct, it means A will connected to plus and C will connected to minus. That case also we will get Vs by 2.
Yes.
And if 2 and 3 will conduct, what will happen? So 2 and 3 will conduct means in A phase no current will be there. If 1 is not conducting and 4 is not conducting, so A phase will be isolated, current will be 0. So voltage in A phase will be 0. So here it is 0. So this, like this we can analyze phase A voltage, and this is the waveform. And phase B voltage is similarly 120 degree phase shifted. Okay. 60 plus 60, 120 degree. And if we'll subtract this one, VAN minus VBN, we'll get this waveform. Is it clear up to now?
Yes.
Okay. So see how we can memorize the formula for this one. So we'll remember the phase for this one. Phase is Vs by 2 into 120, 120, 240 by 360. So Vs by 2 into root 2 by 3, that will be Vs by root 6. And line voltage will be root 3 times phase. Okay. So root 3 times phase will be Vs by root 2. Is it clear? So summary I have written here. How we can remember that I will tell you. So for 180 degree mode, we'll remember the line voltage. Okay. So VL is equal to Vs into root 2 by 3. Same for, so how we can correlate like this. We can remember whatever will be the line voltage for 180-degree mode, same kind of equation will come for phase voltage in case of 120-degree mode, but that will be Vs by 2 multiplied. So Vs by 2 into root 2 by 3. Here line voltage is Vs into root 2 by 3. Okay. So
2 by
in
3.
Vs into, here line voltage is Vs into root 2 by 3, but here phase voltage is Vs by 2 into root 2 by 3. So like this we can remember, and if we know one variable, then other we can calculate. Is it clear?
Yes, sir.
And these Fourier equations, these are the Fourier equations. So for 180-degree mode and 120-degree mode, I have written, you can derive it. So this kind, if you will see this waveform, a line to line voltage. So this kind of thing already we have done in case of, I think, three-phase semi-converter or three-phase full converter, some quasi-square kind of waveform is there. So you see how we can remember this Fourier analysis. So this we can remember. For line to line, it is 4 Vs upon n pi sin n pi by 3 sin n omega t. So what is the line for this one? That same Fourier is the phase for this one. But here it will be V, in case of Vs, here it will be Vs by 2. So that will come as 2 Vs upon n pi sin n pi by 3 sin n omega t. So this 2 we can memorize, and here phase will be 2 Vs upon n pi sin n omega t in case of 120-degree. The line is 3 Vs upon n pi sin n omega t. So like this you can memorize. Okay, if you want, you can try the Fourier derivation by yourself also. If you are not getting Fourier of anyone, you want the explanation of Fourier series, then you can message me in the group. I will derive those Fourier series and I will give. If you are not getting this final expression, okay, then I will derive and I will send in the group. Is it clear? So this thing we have to memorize. This formula for RMS value and this Fourier analysis formula. Is it clear to all up to now?
Yes, sir.
So see, inverter very less number of formulas are there. If you will remember some 10 formulas, then any get previous year question can be solved. So I'm moving to the next part. Some other analysis I have done. See, so sine PWM for three phase. Okay, what will be the sine PWM? Already we have seen for the half bridge converter. So in gate, this part they have asked till now. Full bridge they have not asked. Okay, and three phase also they have not asked till now. So this section they can ask the question. Okay, in this section they can ask the question. So this is the circuit of the three phase. Here it will be VDC by 2, and here also it will be VDC by 2. This is O value, and in case of load also this neutral will be there. So what will be the phase value? Okay, phase fundamental. So VA1, V01, VA1, fundamental of phase A. That will be MA into VDC by 2 sin omega t. Okay. Why? Because if you see the A value, if switch 1 will operate, okay, here VDC by 2 will come. Okay. This I have seen already in simulation also. So this formula is correct only. MA into VDC by 2 sin omega t will be the phase value. Okay. What will be the line to line value? So line to line will be root 3 times phase. So that will be root 3 MA VDC by 2 sin omega t. Is it clear? So this also you have to memorize. Okay. Should I proceed further?
Yes, sir.
Okay. So see, this some analysis I have done for like relation between load current and switch current. Okay, this is very important. So see, if resistive load will be there, okay, what will happen? What will be the relation between output RMS current and switch RMS current? Let's say in question it is given that I is the RMS current across the load. I is the RMS current across the load. What will be the switch RMS current? Okay. So that equation I have derived here. So see, this way, this already we know. Already this one we have drawn. So what will be the switch current? I1, IT I have written here. This is the switch current of 1. Okay. So 1 is conducting from here to here. Okay. So whatever will be the voltage across phase A, that current only flow through one switch 1. Is it correct?
Yes, sir.
So here the current will be, this resistance is R. Okay. So current through the switch will be here Vs upon 3R. Here it will be 2 Vs upon 3R. And here it will be Vs upon
Yes.
3R. And remaining portion it will be 0. Okay. So we can calculate the RMS value of this current. Already I have given one formula. Okay. So like U square into D. U into D formula I already have given. Na? So for constant value, what is the U? U is constant square. Okay. So if we'll see the duty for this one, this is 60. 60 divided by 360. How much? 1 upon 6. And
Yes,
this
sir.
constant line is Vs upon 3R. So I have written here Vs upon 3R whole square into 1 by 6 plus this 2 Vs upon 3R whole square into this duty also 1 by 6 into 1 by 6 plus this third one Vs upon 3R whole square into 1 by 6. Okay. This is the already this RMS trick I have covered previously. So from here I got the RMS value as Vs upon 3R. Is it clear to now? Hello?
So it is switching current.
No, switch 1 current. Current flowing
Switch.
through this switch 1. RMS current, if resistive load will be there, this is the RMS current will flow through the switch. Any switch we can analyze. So I have done for switch 1. Same switch, all switches are working in same pattern. So it will be the RMS value of the all the switches.
Okay, sir.
So see, in terms of output RMS current, how we can relate? So what will be the output RMS value?
Okay.
Normally, output RM line phase voltage will be how line to line voltage will be how much? Vs into root 2 by 3. Okay,
Yes, sir.
and phase value will be root 2 Vs upon 3. So V phase is root 2 Vs upon 3. What will be the output RMS current? That will be root 2 Vs upon 3R. Okay, is
Yes,
it
sir.
clear? And if
Yes,
I
sir.
will divide this output current by root 2, I will get this value Vs upon 3R. Is it clear?
Yes, sir. Yes, sir.
So this is the final conclusion. If I will have the output RMS current is given in objective question, then directly I will divide that output current by root 2, that output RMS current divided by root 2 will be the switch RMS current for the
Ye-
resistive load. Is it clear to all? See, this kind of question can be framed like 1 mark question like output RMS current is given as this much. So what will be the RMS current of the switch? Directly, if you know the relationship, directly you can divide by root 2. That will be the answer. Okay.
Yes, sir.
So moving to the next, see this only, what will be the average value? Okay, same thing. RMS current we have calculated, but what will be the average value? So average means 1 by T into area. Okay. T is how much? 360 degree. Here to here 360 degree. So 1 by T area means this Vs upon 3R into here Vs upon 3R into 60 here and 60 here. So Vs upon 3R into 120 plus 2 Vs upon 3R into 60. Okay. And I am taking common Vs upon 3R. So it will be 120 plus 60. How much? 120 plus 120, 240 by 360. So I am getting 2 Vs upon 9R. IT average. So if resistive load will be there, this formula if you remember, directly we can calculate the average current through the switch. Is it clear to all?
Yes, sir.
Okay. So now same thing I'm doing for 120-degree mode. Okay. So 120-degree mode, we have seen this is the voltage Vs upon 2. It was there. This kind of voltage waveform was there. Okay. So what will be the thyristor current, switch 1 current? So one is conducting from here to here. So whatever will be the voltage across that phase, that voltage divided by resistance. So this is the switch current waveform. This yellow color. Is it clear? That will be Vs upon 2R. And here, is it clear this waveform, switch current?
Yes, sir.
Okay. So we can calculate the RMS value of the switch current. What will the RMS value? It is conducting for 120 degree. So magnitude is Vs by 2R into 120 by 360. How much we are getting?
Yes, sir. 2 root 3.
Vs by 2 root 3R. This will be the switch RMS current. So I want the relation, okay, between the this one. So what is the phase value here in case of 120 degree? That is Vs by 2 into root 2 by 3. Is it correct? And what will be
Yes,
the
sir.
output RMS current? That this phase divided by R. So root 2 Vs divided by 2 root 3 R. This will be the output RMS current. Correct?
Yes, sir.
And if I will divide this by root 2, can we get this value? Is it correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So see here also same relation we are getting. So we can say that in case of resistive load, same relation we are getting. If output current is given, switch RMS current will be output current divided by root 2. Is it clear to all? Should I
Yes,
move
sir.
further? Okay. Okay. So see here also I have calculated the average value. What will be the average value? That will be this into 120 by 360. Okay. So that will be how much? 123 times. So Vs by 6R. This also you can remember. If average current will be asked. So if average and this kind of question can be framed for 2 marks question. Okay. So this step, if you remember also, like see, if you don't forget the formula also, in 2 minutes you can draw this waveforms also. Okay. But if you remember this, it will be like more clear. Like see, some formulas are there that if you are unable to remember, what you can do, you can every morning you can just in night you can remember that formula, but you wake up in the morning and you try to write those formula without seeing. Okay. If you will do for 3 to 4 times, that it will be go in subconscious mind. Okay. Like that you can remember. And some formula you can correlate with other formula and then you can remember. Okay. So I'm moving to the next part. See, this is other type of analysis. So previous all analysis was for the purely
Resistive load.
resistive load. But if
Yes.
RL load will be there, then how we can calculate? Okay. So in this kind of load, what we can do? We can apply the power balance. Okay. So what is power balance? Power balance is Vs Is is equal to output power. Output power will be given in the question. So from this information, we can calculate the source current. That will be the constant DC current here. Okay. So step one, if load will be given, RL load will be given, and the load value will be given, then we'll apply the power balance and we'll calculate the source current. Okay. After that, I am going to plot the switch current. Okay. So see here what will happen. Why I am getting here Is by 2? Can anyone tell? Since 1, 6 and 5 is conducting. Okay. So 1, 6 is connected to top. 1 and 6 is connected to top. And 5 is below. Okay. These are Is current is entering. Okay. So it will be divided half and half in 1
Get by.
and so that's why here it is Is by 2. If 1, uh, 6 and 2 will conduct. So 1 will be at top and 6 and 2 will be at below. So in that case, what will be the switch current? That will be
I.
Is. Okay. Similarly, here we can see what is the combination 1, 3 and 2. So 1, 3 means and top 1 and 3 will be there. Okay. Then it will be divided by 2. Is it clear?
Yes, sir.
So this is the waveform. And in same way, we can calculate the RMS value. Okay. So what will be the RMS value? This Is by 2 whole square into 1 by 6 plus Is square into 1 by 6 plus 1 by 6 into Is by 2 whole square. So this I am getting as Is under root 1 by 24 plus 1 by 6 plus 1 by 24. This will be 6 by 24. Is into 6 by 24. So that will be IS divided by under root 4. This one formula we have to memorize. Source current divided by root 4 for 180 degree mode. Okay, this one I think I took from previous only. That's why it is here. To see this one. See, coming to the average value. What will be the average value? So average value will be 1 by T into area. So IS by 2 into 60 plus 60, 120 plus IS into 60. So how much it will be? 60 plus 60, 120. So it will be IS by 3. Is it clear?
Yes, sir.
Okay. And here same thing I have done for 120 degree mode. Okay. So what will happen here? First we'll do the same thing. We'll calculate the IS. Okay. But if 1 and 6 will conduct, so 1 and 6 will conduct, what will be the in switch 1? That will be IS only. If 1 and 2 will conduct, there also it will be IS only. Is it clear? Clear to all?
Yes, sir.
So from this one, I can calculate the RMS value. What will the RMS value? IS into 120 by 360. That is IS by root 3. And what will the average value? So average will be IS into 120 by 360. That will be IS by 3. Is it clear?
Yes, sir.
So coming to the final conclusion. So how we can remember? See, in case of R load, okay, for both the case, the thyristor and the switch RMS current will be I naught by root 2. Okay, and these two we have to memorize. If you see in RL load, first we'll calculate this thing IS, then average current will be same for both case. That will be IS by 3, and for 180 degree mode, that
It
will
is
be
IS.
IS by root 4, and for 120 degree mode, that will be IS by
IS.
root 3. So this
Yes, sir.
relation we have to memorize. Is it clear up to now?
Yes, sir.
Okay, okay. So I think theory part completed. Let's start with questions. Okay. So some previous year questions I have taken. One by one we'll go. So here 600 volt DC voltage is there and 120 degree conduction. So what they are asking? The load power. Okay. So first we'll calculate the phase voltage. What is the phase voltage for 120 degree? So that is what is line for 180 degree. Similarly will be phase. So phase will be VDC by 2 into root 2 by 3. That will be the phase RMS value. Okay. What will be this value? VDC by root 6. So what will be the power per phase power? Per phase power will be V RMS whole square by R, and three phase power will be 3 into V RMS whole square by R. So that will be the power. Okay. So 3 into what is V RMS? VDC by root 6. So 600 by root 6 whole square by 20. This will be the total power. Is it clear?
Yes, sir.
So 600 by root 6. 1 second. 600 by root 6. How much we are getting? 3 into 600 by root 6 whole square by 20. 9 kilowatt we are getting 9000.
Yes, sir.
So that will be 9 kilowatt. The fill in the blanks type question, they are asking unit also we have to see. So they are asking in kilowatt. Okay, so that will be 9 kilowatt. Clear to all?
Yes.
Okay. So this is the next question. Okay. So already I have given some Fourier analysis of all the converters. So what they are asking here, a three-phase voltage source inverter with ideal devices of 180 degree mode. Conduction mode is feeding a balanced star resistive load. The peak value of the fundamental component of the phase voltage is. Okay.
VDC.
Which one? Which will be the answer? This will be the answer. But we'll see that Fourier already I have given previously. where it is. See, here if you see the phase value of the Fourier. So 2 Vs upon n pi sine n omega t. Okay. So here 2 Vs up 2 VDC upon n pi sine n omega t. This is the Vsn. What will be the fundamental? Or n will be 1. So peak value will be 2 VDC upon pi. It clear? So
Yes,
B
sir.
will be the correct option. Okay. So moving to the next question. So this one, 2012 gate. I think same repeat. This is already same as previous only. So, but here 180-degree conduction mode. 180-degree conduction means we will calculate first line. Line is equal to VDC into root 2 by 3. Okay.
Line
What will be the
RMS voltage.
phase? So phase will be divided by root 2. So that will be root 2 VDC by 3. Line divided by root 3 will be the phase. So phase will be root 2 VDC by 3. VLL by root 3. Okay, that will be this one. So our phase voltage will be root 2 into VDC. How much? VDC is given. How much is the VDC value? It's not given here.
Sir, but it is.
Hmm?
Sorry. I think, sir, it is not mentioned here, but the question is given BDC value.
Yes, sir. 300. 300.
How much VDC value? 300. In question, how much it is? Can you see the previous year gate? I copied
300.
from gate website only. This is 300.
Yes, sir.
Okay. Actually, this question I have copied from gate website only, but maybe they have missed it. So
Sir,
three.
it is given in question number 449, sir.
Okay, okay,
If the
okay, okay.
if the
Here it
BDC
is.
was what?
Here it is
Yes,
given. Okay, okay. It's okay. Okay, okay. So 300 root 2 into 300 divided by 3 into root. How much we are getting? It's like looking.
100.
Some mistake is there. RMS value of the load phase voltage. Can you see the this if you have the question bank? Can you wait? I will also check. 1 minute. I will also check this question if other data is given or not. 1 second. Wait a minute. Hmm. 300 only. VDC is 300 only. So see line to line voltage how much for this one? VDC into root 2 by 3. See this is RMS value. No need to divide it by root 2. Okay. Hello. Am I audible?
Yes, sir. It's only phase voltage.
So phase voltage is
Root.
line divided by root 3. So root 2
Yes.
VDC by 3. This will be the
Yes.
value. So root 2 into 300 by
Divided by
3. How much? 100 into root 2. That will be 141.4, I think.
yes, sir.
This will be the answer. And second part, what we have to calculate? Power
Power.
consumed by the three-phase load. So 3 into B RMS whole square by this will be the power. So 3 into 141.4 square by 20. How much? 3 into 141.4 square divided by 20.
3 kilowatts, sir.
Ah, yes, so it will be 3 kilowatt. They will be the
Yes,
correct option.
3
Okay,
kilowatt.
okay. I'm
It's
moving to
approx 9
the
triple line.
yes, 2 triple line. So it will be approximately 3 kilowatt only.
Yes, sir.
Moving to the next question. So this is asked in gate 17, I think, or no, 16. I think 16. 16 or 17. So DC
Yes.
is 600 volt. Okay, but load is delta. So load is delta means what will be the voltage here?
Phase
That will
voltage
be
will
line to line voltage. As
Yes,
per
sir.
inverter, if you'll see, this is A phase and this is B phase, or let's say B phase, this one. So across each phase in the delta, that will be the line to line voltage of the inverter. Okay, whatever inverter is feeding to this load, across these 2 points will get the line to line voltage. For 180-degree, what is the line to line voltage? That is Vs into root 2 by 3. That is line to line. Is it clear?
Yes.
So that will be 600 into root 2 by 3. And per phase power will be V RMS whole square by R. So three phase power will be 3 into this V RMS whole square. So 600 into root 2 by 3 whole square divided by 30. Is it clear?
Yes.
So how much we are getting for this one?
The line voltage is 4.489.89 watt power.
Power we can calculate directly. 1 second. 3 into 600 into under root 2 by 3. Second, whole square divided by 30. 24,000 we are getting, means 24 kilowatt.
Yes, sir. 2400, 24,000.
Okay, so this will be 20. Like this only someone asked, like what will be the value in case. See, load is delta, but voltage whatever we are getting here, that will be the line to line voltage. So per phase will be V square by R. Three phase means 3 into V square by R. V line to line. Because here we are getting V to line to line. So 3 into V line to line whole square by R. That will be the power of the load. Is it clear?
Yes, sir.
1 second. One more question I took. See, this one is not a inverter question. Like just diagram they have given. But it is basically a power flow question. Just diagram is given for confusing. Okay. So power is 5 kilowatt. Okay. Power is 5 kilowatt. Unity power factor. Okay. So what will be this IS? If unity power factor means 220 into IS into rest will be how much? 5 kilowatt, 5000. What will be the IS value here?
5,000 divided by 22.72.
So IS is 22.772. Okay. So if you see here, what will be the IS excess? Excess is given somewhere 5
Yes,
milliamp.
sir.
So what will be the
5
X
million.
value? 2 pi into
Well,
5 milli. How much it will be?
2, 3, 157,
157 we are
3,000,
getting. But this is milli.
157
This is milli.
millihen, 10 to the power minus 3. So 157.
We are getting 157.
Yes, sir.
2 into 1 second. 2
And
into it will not come that much big, I think. 50
yes,
into
sir. 150.
5 into 10 to the we are getting that much only. I will also calculate. 1 second. 10 to the power minus 3. 1 by 10 pi we are getting. No, no, 1 second. So see, this is 5 milli.
It's
Okay.
15.707, sir, that one.
15.707. This
Uh,
one we are getting. Okay. So what will be the this value I into x? This length is I into x. This is Vs. So this will be 15.707 into 22.72. That one will be this value. We can calculate delta value from this diagram. Tan delta equal to 15.707 into 22.72 divided by 220. Okay.
So this is not for not in inverter chapter, no sir.
No, this is in inverter only.
Means here input is AC, output E load, no sir.
See,
Battery.
but that is okay. But that is okay. It's looking like rectifier. But if you'll see here, this is how much switches are operating at 20 kilohertz. Okay, something they are giving. It's inverter only. So what will happen here? Some pole voltage will generate. Okay, high frequency voltage will generating. So what? How power will transfer? So here one fundamental voltage will be there between these 2 points. We are getting.
Oh,
If
okay
we'll
sir.
if we'll apply high frequency sine PWM, then what will happen? Here a high frequency voltage will generate, but that high frequency voltage will have a sine component. Okay, you are getting.
Okay, okay sir.
So that sine component will generate such that some phase difference will be there in sending in voltage. Let's say this is sending in voltage. Okay, and this is receiving in voltage. Receiving in means between these 2 points. So PWM is generated such that it will create a difference of delta between this sending in and receiving in.
Lagging current.
So like already that power, already this kind of concept we have studied in power flow equations. Okay. So same thing here, but here the thing is only fundamental will contribute to the power. So here high frequency plus minus will be there. But out of this one, the 50 hertz component will be a sine wave. That will be M into VDC, peak value. Is it correct? Clear?
Sir.
So between this sine wave and this sine wave, power will flow. Okay. So how it will flow? We'll do the modulation index such that this is 220. Okay. If I want reactive power inject this one, so I will create here voltage such that here the sine wave which is generated will have lower magnitude than this one. Okay, if this is 220 and 220 root 2 peak, so here whatever will be the fundamental value, let's say that has 210 into root 2 peak. So if peak is less here, then reactive power will flow from here to here. Okay, and if I will create a phase shift between this voltage and that fundamental voltage, so that is called as load angle. Okay, is it clear?
Delta.
So
Sir.
So how it can be done? How it can be done means I will explain with respect to experimental. So how in experiment we can do? So let's say this is 220 volt AC. One voltage we know. This voltage we already know. Okay. This information we have. According to this information, what we will do, we will track this theta value by using on term is there PLL. So we'll use PLL, we'll track this theta, and based on this theta, I want some difference. So I will shift that waveform, and accordingly, that modulated signal for this one will be shifted by delta value. Okay. So then it will, this is 0, so this will be minus delta. So this is Vs angle 0, then here it will be Vr angle minus delta. Then only power flow will happen between these two voltage source. Is it clear?
Yes, sir.
Okay. So how much value we are getting from this one, delta? Anyone take? Nine point something we are getting? 9.2 or 10 inverse 15.707, 10
Sir,
inverse.
58.34, sir, that one.
Maybe some correction calculation mistake we have done. We'll see it again. 15.707,
Yes, sir.
22,
58.34 degree.
72 divided by 220. 58.34 we are getting. That is incorrect, I think. We'll see once. Uh, that charge a battery, 400 volt battery is there. Source is
Power is
220 volt
22.
RMS, 50 hertz. Unity
That's
power
sir.
AC side 5 millihenry and the switch operate at 20 kilohertz. Fundamental frequency is not given anywhere.
I think
50 hertz, 50
yeah.
hertz only. Okay. So we'll calculate once. 2 pi into 50 into 5 millihenry, 2 into, 2 into 5 into 50 into 5 into 10 to the power minus 3. This one we are getting 1.57, na? 1.57 this one. Can you check
Yes,
once?
sir.
1.57 only it will come.
Yes, sir.
So this will be 1.57. 1.57 is the x value. Okay. 1.57 into 20 will be 22.72 will be the IA axis. So here it will be 1.57. 0.5707 into 22.72 divided by 220. So that will be 10 inverse 1.5707 into 22.72 divided by 220. 9.21 we are getting. Is it correct?
Yes, sir.
See. So how new question can be framed on this? That I will explore little bit. One second.
Yes, sir.
I will just analyze and tell you how new question they can frame. So this will take on the next page. So see here it is there. So they can give data like this. This is a phase voltage, our phase voltage. So they will give a waveform. This is, let's say this is phase voltage. Our VS. This is VS. So this is VS. Okay. Then what they will do? They will give a modulating signal of the switches. Okay. That will be, let's say this is modulating signal. Okay. And here they will give a theta value. Theta will be there. That will be how much? Let's say 30 degree they are giving. Okay. They will give, this is modulating signal of the switches. So, and carrier signal also they will give. So this amplitude, let's say they will give 0.8. Okay. And carrier will be 0 to 1. Just like previously it were there, -1 to 1. Okay. So this information they will give. This is the source voltage waveform. This is the modulating signal which is shifted by 30 degree, and this amplitude is this one. So then they can ask how much is the real and reactive power delivered by source to the battery. Okay, so what we can do, we will calculate the fundamental voltage here. Okay, so what will be the fundamental voltage? That will be MA into BDC by root 2. Okay, is it clear? So we have 220 angle 0, but what here between reactance is there, and here the voltage will be this MA into VDC by root 2 angle this minus theta. Is it correct? Why it will be minus theta? Because this will already modulating signal is shifted by theta. So the fundamental value of the output voltage here, the voltage we will get, let's say this is source voltage. Okay, but across these 2 points the voltage which we will get, that will shifted by the theta value, that fundamental value. Okay, so if this is 0, this is how much? Minus 30 or plus 30?
Minus 30, sir.
Minus,
Lagging?
plus.
Hmm? No, if it will come earlier, then it will be plus. Hmm?
Yes, sir. Yes, sir.
But
Yes.
it is lagging, so this will be minus 30.
Yes.
So whatever will be the fundamental voltage we will get across these 2 points, that will be this value. Okay, and already the source value we know, this theta we know. So like that question can be framed based on this. That will be the power electronics question. But this question, it was not a power electronics question. Simply some power they have given. It's just like a phasor question. Is it okay?
Yes, sir.
Okay. So almost all three-phase questions I took. Like inverter, more questions was not there. All three-phase questions I have taken. Other single phase also I have taken. So this was the last question. Any other doubt if you have, you can ask.
Sir, in this we have to in invert D2 DC to AC, we have to find that power factor also, no, sir.
Which one?
AC parameter. AC parameter, sir. Output power factor.
Here in this question.
Previous, sir. In three phase star load or delta load.
Okay, here you are asking.
Yes, sir.
See, power factor means it will be unity only because resistive load is there.
Okay.
Load, if load will be given, let's say this is Z load. Okay. Balanced load will be given. Then what will be the power factor? Power factor means that cos phi. Okay. So phi means what? That will depend on Z. Z is equal to R plus Jx. Okay. So the real power will be 3 into V line to line into I phase into cos phi. That only will be the value. Okay. So phi will be tan inverse x by R based on the load. This is R plus Jx. The power factor will be tan inverse x by R. Is it clear?
Sir, so we have
You
like
can.
this also, cos pi equal to R by Z. That method valid, sir.
Okay, I think that also R x z. Directly you can do cos phi is equal to, this is theta I am calculating or phi I am calculating. After that you have to apply cos phi. Directly you can from this triangle you can do cos phi is equal to R divided by z. Is it clear?
Yes, sir.
Okay. Any other doubt is there? Otherwise you can post in the group also. Anytime if I will be free. Like in some question, if you are getting a struggling, like you are not getting the solution, so that group is there. Anytime you can post. Like see how we can use the groups. Initially, students will solve the question. If none of them are able to solve the question, that will be difficult question. Then I will look into that question. That way it will be good, I think. Because if other student knows the question, if concept will be clear between all of you, then it will be good. Okay. If none of them will be solving the question, like that will be difficult, then all of you can refer that question to me. Then I will look into that question and I will post the solution. Will it be okay?
Okay. Sir,
Yes,
so
you can.
little bit of concept. We will explain the single pulse width modulation.
Single PWM, yes. Should I go to
Yes, sir.
that? Should I go previous?
Yes, sir.
Okay, 1 second. Single PWM I have already discussed. It is there only. This only you are asking?
Yes, sir.
So see what we are doing here. In single PWM, this reference signal will be a square wave. Okay. I want 50 hertz. So here to here it will be 50 hertz. Here to here it will be 50 hertz. Okay. And triangular signal also will be of the same frequency. And this is the logic we are using. So if carrier signal will be greater than reference signal and logic I am using. So if these two criteria will be fulfilled, then my switch 1 and 2 will be on. Okay, this is output voltage. So if you see here, here to here. So in first section, the VC is greater than VR for here to here, and this VR is also greater. These two conditions are satisfying. Then what am I doing? I'm turning on switch 1 and 2. So in this case, what will be the output voltage? That will be this one. This red color waveform is the output voltage. So here, this point to this point, switch 1 and 2 is on. Again, next case, when VC is less than VR and VR is less than 0. So where VR is less than 0? In second half cycle. So VR is less than 0 already. But VC should be less than VR. Okay, so VC is less than VR here. So it will give S3 and S4 pulses during these 2 points. So we will get this kind of output voltage. Is it clear? So this is
Yes,
called a
sir.
single PWM. What will be the value? So I am calling this pulse width as 2D. Okay. This total width I am assuming as
Yep.
2D. So
2D.
this is pi. This is 2 pi. So what will be this mid value? Mid value will be pi by 2. So here it will be
Yes, sir.
pi by 2. So if this is 2D, this starting point will be pi by 2 minus d by 1 second. I think here it will be something mistake we have done. It will be d or
Sir, we assume pulse
Pi.
with D.
if it will be d then, no?
Yes, sir. If D, then
I
pi by
think
2 minus
some
D by 2.
okay. If it will be d, then it will be pi by 2 minus d by 2. So
If we
based on
assume
this only
2D,
we
then pi by 2 minus D.
okay. Here I have written there. So here it was d. So then pi by 2 minus d by 2, pi by 2 plus d by 2. But while doing
Yes.
the Fourier analysis, I have written like this. This I assumed as 2d. So then it will be pi by 2 minus d and it will be pi by 2 plus d. Is it
D.
clear?
Yes. Yes, sir.
So same thing I have done the Fourier analysis. This will be the output voltage. Okay. What will be the RMS value? RMS value will be, this is conducting for how much? 2D and 2D, 4D. So in 2 pi, it is that waveform is appearing for 4D. So 4D divided by 2 pi. This is the actual RMS value. Okay. And Fourier analysis, this will, if we'll see, this is following odd and half wave symmetry. Half wave symmetry means if it will do x t minus t by 2, that will be minus of xt.
Yes, sir.
And x minus t is equal to minus xt. These two things it is following. So,
Yes, sir.
so bn we can calculate. Already I told t by 4 by t. That short formula 4 by t 0 to t by 2. That will apply. That only I have applied here. And this is clear. I think this calculation is okay. Whatever I have done. Should I explain this one?
Yes, sir.
Okay. So see, that Bn only will exist. Bn will be 4 by t 0 to t by 2 xt and sine n omega t dt. Okay, this is the formula. So how is the period? 4 by 2 pi. and it will pi by 2 minus d to pi by 2 plus d. So pi t by 2 will be pi. So 0 to pi means our signal is available from pi minus d, pi by 2 minus d to pi by 2 plus d. So that only I am taking here. Okay, because otherwise signal is 0.
Yes,
And
sir.
Vs sin nt. So where is omega? Omega will be 2 pi by t. So 2 pi by 2 pi, omega will be 1. Since period is 2 pi. So sin nt into dt. Okay. So here if you see 4 divided by 2, so it will be 2 Vs upon n pi into sin nt. What will be the integral value? Minus cos nt.
Oh, yes,
So
sir.
pi by 2 minus d, pi by 2 plus d. Okay. And here if you see, this will be first term will be minus cos n pi by 2 plus nd plus cos n pi by 2 minus nd. Okay. So what is cos a plus b formula? That cos a plus b formula is cos a into cos b minus sin a into sin b. And cos a minus b is formula is cos a into cos b plus sin a into sin b. Okay.
Yes,
So here minus is multiplied. So minus cos A into cos B plus sin A into sin B. Okay. Plus cos A into cos B plus sin A into sin B. So cos A into cos B will be cancelled. That will be 2 sin A into sin B. Is it clear?
yes, sir.
So 2 will multiply here. So 4 Vs upon n pi. That will be 4 Vs upon n pi. And sin n pi by 2 into sin nd. So sin n pi by 2 into sin nd. This is Bn value. Now, but Fourier value will be Bn into sin n omega t. Okay. An cos n omega t plus Bn sin n omega t. But Bn is this one. This is the sin value. Is it clear? So this will be the Fourier of that single PWM. Anything else I should explain? See, this one we are using to eliminate any harmonics. Okay. So sine of nd. This if this term will make 0, I want to eliminate third harmonic. So I will make sine of 3d is equal to 0. Okay. So 3d will be pi, 2 pi, 3 pi, and d will be pi by 3. Pi by 3 means how much? 60 degrees. So
60 degree.
if we'll set the pulse width 2d is equal to 120 degree. So if I will set the pulse width, this pulse width 120 degree, then output will be free from the third harmonic. Okay. Is it clear?
Yes, sir.
Okay. Anyone have any other doubt? Have you solved other like rectifier and inverter questions previous year? Almost most of the questions I have taken, but if any other some questions are left, if you are getting in any question, any power electronics or other subject also, you can post in the group. If no one will be solving, then I'll pick that question. Okay.
Okay, sir.
So this much only. All of you are writing the test series, right? How is the performance test series? When is the exam? Like
11 February.
11.
11. Okay. So see, inverter, how much I have covered, this formula you should remember. Maybe 2 to 4 marks you will get. Okay. Most of the things I have covered. It will not come out of this. Okay. Rectifier also, all the input power factor formula you should remember. Okay. And okay, rectifier also most of the things I have covered. So there also either they will ask displacement factor, distortion factor, or THD. Okay. Or some. Okay, if you see the previous year question, then there you will get the variety of questions. Similar kind of pattern will be asked. So if now you should focus only on get previous year. Okay. Try to solve as much as get previous year questions. Daily you should give 2 hours for mathematics, 2 to 3 hours. Okay, revise because math portion will be 15 marks, I think. So 15 marks means 15, 12 almost it will be there. So you should allot daily to more than 2 hours also. If 2 hours will be okay. 2 hours if you are solving daily different math questions, then it will like you can divide time for different chapters like complex is there. Okay, then vector is there. So let's say today you are solving complex, vector, and differential. Like this daily if you will do, you will memorize the formula. Okay. So daily 2 hour maths. Other time you can solve. You can divide to some revision of the formula to other subjects. Okay. So for today, this much only. Like if you have any other doubt, you can ask. Otherwise, you can post in the group. There also I will be available. So how many of you have it is in third year of engineering or completed like that?
Sir,
Hello.
completed engineering.
Okay.
I complete in
Okay. Okay. And which year?
sir.
Which year you have completed? Like I'm asking, like year of passing.
Sir,
It is
this
your
year,
this year only you have
2020. Yes, sir.
23 you have completed.
Yes, sir. Yes, sir.
Okay. So you practice, see, gate means practice as many questions, collection of concept is required, and you should practice question always with virtual calculator. Okay. Like I have installed in my desktop and write as many test series as possible. Okay. Anyone if you writing the mock text, like full marks, 100 marks text.
No, sir.
Okay. So, okay, it's okay. But now time is less. So what my suggestion will be, focus more on the gate previous year. Okay. Now onwards, more on the previous year. See, your strategy should be 2 hour math and other than gate previous and plus formula revision. These three things you should follow because time is less. Now you cannot go on test series because 10-20 days is remaining. This sequence you can follow. It will fetch you good marks. Okay. So I hope all of you have learned something from my side during this power
Yes, sir.
electronic course. I
Yes,
tried
sir.
like best whatever trick I have learned till now with my personal analysis. Like any coaching material, if you will follow this kind of analysis, you will not get. And
Yes, sir.
question bank also, they will not solve all the, like directly they will provide the answer. Some question they will not solve. Difficult question will be there that they will leave. Okay. So that RMS short trick you should remember. That will be very helpful. Whatever I have given. RMS short trick. That will save your time. Okay. So thank you all.
Thank you, sir.
This was the last session. Very good. Like some serious people have attended till last. I think it will definitely it will help you to solve the power electronics based questions. Okay. So thank you all.
Thank you. Thank
All
you,
the
sir.
best for
Thank
the
you, sir.
GATE exam. All the best. Thank you all.
Thank you, sir.